Okay, so we're going to talk about today and tomorrow something called intercept form. What do you think intercept form is going to help us find?
The intercept.
Yeah, the x-intercept. So when we talked about vertex form last week, it was really easy to pick out the vertex. When we talk about intercept form, it's going to be really easy to pick out the intercepts. Okay, so intercept form, we're going to have our a, but instead of ax squared plus bx plus c, or instead of a times x minus h squared plus k, we are going to have a times two factors, x minus p and x minus q. And why we call this intercept form is because if we were to take this and say, hey, what happens when it equals 0? We would get our x-intercepts. Okay. Now, if we have a parabola that has two intercepts, what do we know about the vertex? Where's it going to be?
In the middle.
In the middle. So we can find the middle. What's the halfway point? What is in between exactly halfway of our two intercepts? And we're going to know the axis of symmetry. We're going to know where to find the vertex. Okay. That is our goal today.
What if it doesn't intersect?
Ooh, what if it doesn't intersect the x-axis? What would that look like?
Under it or over it?
Well, you're gonna have to be more specific like that.
It can be over it. Well, it could be if you put it
Over the x-axis?
No, or underneath.
Underneath the x-axis?
No, like upside down. Reflected, but the
So
vertex-
below the x-axis, but upside down. That's not going to have any x-intercepts. Neither would this guy right here, Connor and Brooks. So you're right. We could have a situation where we don't have any x-intercepts. If we did, you would not be able to write it in intercept form. Okay, so we would not run into that in this form. Now we could run into that in our other two forms, okay? And we probably have like number 10 on your homework, but we can only do this if there are actually x-intercepts, okay? All right, so let's come down here. And I want you, this is like the bottom of that page where it says notes. I want you to write f of x is 1/2 times x minus 4 times x plus 2. Write that for me. Tell me some things that we know. Henry, what's one thing we know? The a is 1/2. And since the a is 1/2, what do we know about our parabola? It's going to be wider than normal. Okay, Maddie, what else do we know?
P is positive and Q is negative.
Okay, so we know that this 1/2 is creating a wider parabola. Okay, what we're going to do is we are going to say, okay, if we set this equal to 0, then we know that x equals 4 and x equals -2. Do you remember when we did that? Okay, take each factor, set it equal to 0. Okay, so what this is telling us right here, these are our x-intercepts. What's the problem? Did you say what?
No.
Oh, you have come back. Connor? Are we good? Okay, so let's talk about what this looks like. We know that at x equals 4 and x equals -2, our parabola intersects our x-axis. We know a little bit about what that's going to look like, right? Which way is it opening? We know it's opening up. Okay. So we know we have the coordinates -2, 0 and the coordinate 4, 0. Okay. Now let's talk about where our vertex is going to be. Okay. How do we find the x coordinate if we know that we are on the x-axis at 4 and -2? How do we get the middle? Okay, we find the median, right? So the x coordinate of our vertex, we're going to take 4 and -2 and average them. What do we get?
1.
I think we get 1. And does that make sense? Is 1 in between halfway 4 and -2?
Yeah.
Okay. Yes.
I thought that dividing across our axis of symmetry.
Yeah, that's what we're getting. The axis of symmetry goes through the vertex. Okay. So now to get the real vertex, we need to actually plug 1 back in. So we need to come back up to our equation, 1/2 times x minus 4 times x plus 2. Okay. What's this number? 3 times -3. So what is 3 times -3? -9 times 1/2. So -9/2. So our vertex is at 1 -9/2. Our intercepts are at -2 and 4. Boom, we have a parabola. We don't need any other coordinates. We've got the shape. Are you judging my parabola?
I mean, it's just 9.5 to 9/2.
I like my job. Is that better?
That's good. That's good.
Okay, what I want you to do, I want you to go to number 2 on that next page, and I want you to find me, you don't have to graph anything, can you please find me the x-intercepts and just the axis of symmetry? You don't even need to find the full vertex, just the x-intercept and the axis of symmetry. Ready, set, go.
Is this the lesson? Like until we get our worksheet?
I've literally done one problem. Oh, what? No, he's a, like, he has dirty blonde hair. That is dirty blonde. Nope. Harry has red hair. Eli does not. Okay. Where are our x-intercepts? Okay, 2 and 3. And if our x-intercepts are at 2 and 3, then halfway in between our axis of symmetry would be at 2.5 or 5 halves. I don't care how you write it. Okay, I'm okay with 2.5. Okay, Kari, are you okay with that? Okay. Okay, so we're gonna do 2 graphs before I get you to your homework. All right, let's graph number 4. I like number 4. 4 looks really nice. Go and make an XY chart. How many points are we gonna have in our XY chart?
3.
We're gonna have 3 points. 2 of them are x-intercepts, 1 of them are vertex. Okay, DJ, give me 1 x-intercept. Okay, so we're gonna call them 3, 0 and 1, 0. 1, 0 and 3, 0. X-intercepts, the X is our number and the Y is the 0. Okay. He got those by taking X minus 3 equals 0 and X minus 1 equals 0. So X is 3 and X is 1. Okay. Now, our axis of symmetry is going to be exactly in between there. Oh, that was like so easy, wasn't it? It's at 2. I'm going to give you and your partner 45 seconds to figure out what the Y value is for X equals 2. Okay, on the count of 3, tell me your what Y value. 1, 2, 3. 4. We just all counted to 4. Okay, so let's talk about how it is a positive 4. So this is negative 4. Can you look up here? Negative 4 times negative 1 times positive 1. I am not doing a good job of graphing these today.
Whenever I draw this, I just want to make it more.
Yeah, don't do that. Make sure there's a curve to that. Now, does it surprise you that it's skinny? No, we knew that. We knew it was going to be reflected and vertically stretched, aka skinny, because of that negative 4.
So reservoir.
No. So typically,
Because you said we can use that number.
I cannot say you could use slope.
You keep bringing smoke to it.
Okay, but no.
We'll get it up. This short or something.
So here's the deal. We typically have a parabola with coordinates at 1, 1 and negative 1, 1. When we have a coefficient, then it multiplies to the y. So these go up to whatever a is.
Exactly. So it's like,
Oh, it is not exactly like rise over run. No, not anywhere. Okay, we're gonna go to number 6.
well, instead of rising around, it's just a rise. Oh, well.
It is a stretch. We multiply.
That is.
Okay. This is interesting. What are our x-intercepts? Is this in intercept form?
No.
No. Which means what are we going to have to do? Stop talking about baseball before I lose my mind. Okay. What are we going to have to do if it's not in intercept form and we've been graphing in intercept form? What are we going to have to do, Maddie? We're going to have to put it into intercept form. And how are we going to take ax squared plus bx plus c and put it into intercept form? By factoring. Our favorite word. Okay, so I'm going to give you 20 seconds to factor x squared plus 2x minus 15. Just fill out the parentheses. Ready, set, go. It's even a nice one because a is 1. Real quick, consult with your elbow partner. Make sure you factor it to be the same thing. Carly, what'd you get? Can you just tell me what you got for the factors? X plus 5, x minus 3. Good?
Yeah.
Okay, now Carly was trying to go one step further, okay? Because we have the x plus 3 and x minus 3. What did I just say? I don't know what I just said. Because we have x plus 5 and x minus 3, we know that negative 5 and positive 3 are our x-intercepts. What? Okay. We'll make it work. So we have a coordinate at negative 5, 0 and 3, 0. Okay. All right. Write down what you think the x coordinate of the vertex is right now. Write it down. I said write it down. Henry's very excited about it.
Chill out, Mr. Slow, okay?
Hey, where's our axis of symmetry? Gabe.
Come on, Mr. J.
Okay, so Ian, since you're very excited, how did he get x is negative 1? Okay, it's in the middle of our two x's. If you need the math, we take negative 5 plus 3 and divide that number by 2. Okay, now what happens when we plug in negative 1? Does we get 4 times negative 4? Is he right? Negative 16? Okay, we could also, instead of using intercepts form, we could say -1 squared plus 2 times -1 minus 15. Okay, you can plug into this form or you can plug into this form. It's not going to matter. Either way, we get -16. Do I have 16 tick marks? No. So how about I count by fours? Or would counting by twos be better? How about 2, 4, 6, 8, 10, 14, 16. So there. Put that guy there.
Yeah.
Oh, man. You couldn't stop me before I got further. Good thing I have my undo button, huh? Here we go. Okay. I think graphing in this form pretty slick. I think it's less work. Yes. So we know that it's upside down if there's a negative, right? If A is negative, we know it's going to be upside down. And if A is positive, we know it's going to be going up. And we know if we're doing intercepts form, I'm only going to give you intercepts. Like I have to give you a problem that has X intercepts. Otherwise, we can't write intercept form. Okay. So